Today we're going to talk about integer exponent. For the integer exponent, we start from the simple one. Start from the addition, simplification of the addition. We know that if it's addition with the same number, for example, 2 plus 2 plus 2 plus 2, we can simplify it written as 5 times 2. And if we use x to replace a number, it will be x plus x plus x plus x plus x and equals 5 times x. We can write it as 5x or 5 times using a dot to represent the times. So similar to the multiplication, if it's 2 times 2 times 2 times 2 and times 2. So we can write it as an exponent, which means it's 5 times 2 to multiply. So we write it as 5 to the 5th power. Similar, if we use x to replace it, which means x times x times x times x and times x is 5 times x to multiply, which means x to the power of to the 5th power. So this means we can use a simplified written style to express the multiplication with same number. Okay, so based on the definition, the first one is the base, the number 2 is a base, and number x is a base, and the number 5 means to the 5th power. It means it's a power. So base and power. Okay. Then we can explain the example, the operation of the exponent. Okay. So next we see the example 1. What is 2 to the 5th power times 2 to the 6th power? So it means 2 to the 5th plus 6th power equals 2 to the 11th power. But why this operation is correct? So we explain 2 to the 5th power means 2 times 2 times 2 times 2 and times 2. It means 5 2's multiply, and 2 to the 6th power equals 2 times 2 times 2 times 2 times 2, which means 6 2's multiply. So 2 to the 5th power times 2 to the 6th power equals 2 times 2 times 2 times 2 times 2, which means 5 2's, times 2 times 2 times 2 times 2 times 2 times 2, which means it's 6 2's. So in total, it's 11 2's multiplied together, right? So it equals 2 to the 11th power. It means 11 2's multiplied. So it means 2 to the 5th power multiplied 2 to the 6th power equals 2 to the 5 plus 6 power equals 2 to the 11th power. This is for the two components multiply, how we calculate. So we add the power and the base has no change. Okay. Example 2. What is 3 15th, 3 to the 15th power divided by 3 to the 12th power? So it equals 3 to the 15, take away 12 to the power of 15, take away 12. It equals 3 to the 3rd power. Why? Why it's like this? So we can expand it as 3 to the 15th power divided by 3 to 12th power equals 3 times 3 times 3. In total, it's 15 3, right? So it's 15 threes. In total, it's 15 threes. And divided by 3 times 3 times 3 times 3 times 3. In total, it's 12 3. So we can cancel 12 3 from the numerator and denominator at the same time. So then we're going to have 3 times 3 times 3 and above in the numerator, and we're going to have 1 in the denominator. So this equals 3 to the 3rd power. So this means it's a division. If for a division of exponent, we minus the power and the base has no change. Okay, so this means for a exponent, multiplication of the exponent with the same base, a to the power of m multiply a to the power of n, it equals to a to the power of m plus n. And a to the power of m divided by a to the power of n, it equals to a to the power of m minus n. Okay. That's for today's